Problem number 3. In the section of a regular polygon shown below, the measure of angle BCA is 5 degrees, and the length of each side is 5 centimeters. What is the perimeter of the polygon? Alright, well, if this is a regular polygon, then this side is equal to this side, which is, they're both equal to 5 centimeters, and we're told that. And if we knew how many sides we had in this polygon, we could just take 5 centimeters times the number of sides and we'd have it, right? But we don't know how many sides. We just know that it's a polygon, and it's a regular polygon, okay? So regular just means that all the side lengths and all the angles are the same, okay, for all the, for the polygon. But we don't know how many sides there are. So that's the trick in this problem, all right? So if you take a look at this this diagram here, you can see we're showing a section of a polygon, but you can also see that we've got a triangle here, ABC. And if we know that this is 5 degrees, and we know this is a regular polygon, so the side lengths are the same, so this triangle, this kind of flat triangle, ABC, makes an isosceles triangle, right? Isosceles triangle. Okay, isosceles just means it has two sides that are the same. And if the sides are the same, then the angles opposite them have to be the same. So this is 5 degrees. Okay, this angle here. And then we can figure out this angle B up here, this ABC angle. Because we know that the sum of the angles in the triangle have to be 180 degrees, and so we've got 5 degrees here, 5 degrees there, that makes 10, so we need this angle to be 170 degrees. Okay? So we have a regular polygon in which the interior angles are all 170 degrees. Okay? So what polygon has interior angles of 170 degrees? Well, I don't know that right off the top of my head. But one thing I do know is that a triangle has 180 degrees. That the sum of its interior angles are 180 degrees. If we have a quadrilateral, which has 4 sides, the sum of its angles, its interior angles, is 360 degrees. Okay, I just know that because I memorized it, but I also know it because I can actually divide this quadrilateral into 2 triangles, and I know the sum of the angles in this triangle, right here, here, and here. Alright, that's 180 degrees, and the sum here has to be 180 degrees. So if we add those together, it's just 2 times 180, alright, because it's just 2 triangles. And if we keep going, let's look at a pentagon, okay? Pentagon has 5 sides. Oops, I'm not drawing it's not a regular pentagon, but it has 5 sides, okay? So now we could figure out how many, what the sum of the interior angles is if we break this up into triangles, okay? So if we break this pentagon into 3 triangles, then there has to be 3 times 180 degrees. The sum of the interior angles have to be 3 times 180, okay? Because you can see that the interior angles of the pentagon are just going to be the sum of the interior angles of the 3 triangles, the way I've drawn it here. Alright? You see that? And you can see there's a pattern going here. Let's go on and just do one more for the fun of it. Let's do a hexagon. That's 6 sides. Okay, it's not going to be a very fancy hexagon. But I can break a hexagon into how many triangles? I can break it up into 4 triangles. So the sum of the interior angles of a hexagon is 4 times 180 degrees. Alright? There's a pattern here, right? So essentially so this 4-sided figure has 2 times 180 degrees in its interior angles. For a pentagon, which has 5 sides, we have 3 times 180 degrees for the sum of the interior angles. And for a hexagon, which has 6 sides, we have 4 times 180 degrees for the sum of the interior angles. Okay, So it looks like if we just take the number of sides and subtract 2, then and take it times 180, then we will get the number of degrees in the sum of the interior angles. Okay, so if we have an n-sided polygon, if we just subtract 2 from the number of sides and take that times 180 degrees, then that should get it for us, right? Because there's a pattern here, and you could see that if we had a 7-sided figure, we should be able to break it up into 5 triangles, and so on. An octagon, we should be able to break that up into 6 triangles. All right, so if we know that formula, now you can either memorize that, or I'm not very good at memorizing things, so I prefer to think of it, to remember the pattern. For some reason I can remember patterns and reasoning better than I can remember just formulas cold, unless I use them all the time. But I don't use this all the time, so sometimes I have to think about it to remember what it was. So, alright, so if we have this n-sided, we're trying to solve for n, right? So if we know that the sum of the interior angles of this, whatever this n-sided polygon is 180, I'm going to write it like this, 180 times n minus 2. And if we know we have n sides, right, and n angles too, because if we have a polygon with n sides, it has n angles as well. So if I want to find the number of degrees in one interior angle, okay, this is the sum of the interior angles, sum of interior angles, and if I divide it by n, then I'll get the okay, so that's just the numerator. Hopefully it doesn't look like that. So this is the sum, and if I divide it by n, then I'll get the number of degrees in one interior angle. And I know I'm looking for the polygon that has an interior angle of 170 degrees. So if I set that equal to 170 degrees and solve for n, then I'll be able to figure out how many sides this polygon has. And then I'm home free, right? Alright, so let's figure this out. I'm going to cross multiply. I'm going to actually multiply both sides by n to get this fraction off the bottom here. So I get, or this denominator here. So I'll get, and I'm going to multiply through by 180, okay? So I get 180n minus 360 is equal to 170n, okay? And I'm going to scroll down a little. And that's easy to solve, right? I'll just subtract 170 from both sides. Or sorry, 170n from both sides, and I get 10n. And then I'm going to add 360 to both sides. 360 plus 3... backwards here. Plus 360, okay? So I get 10n is equal to 360. And so then n has to be 36. So that's telling me that this regular polygon is a 36-sided polygon. Alright? And then we have to remember that what we're trying to figure out is the perimeter of the polygon. So the perimeter will just be 36 times 5 centimeters, which is just equal to 180 centimeters. Alright, so there's your answer. Once you've got the number of sides, that's the tricky part, you can just multiply by 5 centimeters to get the perimeter.